We're going to talk about some bioenergy as a driver for economic growth and energy security and resource sustainability. With the pointer moving forward. Right, let's dive right in. More than $350 million is spent every day on foreign oil imports. Let's let that settle in. That's a lot of money. It's dependent, that's dependence on foreign oil that can leave the US vulnerable to disruptions in supplies and contributes to the trade deficit. Yes, as we've seen, there have been significant increases in the production of US oil, and that's great. But are there other options to supplement that? And hopefully through the talk, I'll be able to bring you to a point where you say, yes, biofuels can supplement the crude oil that we're making in the US as well. Let's talk about the transportation sector. 70% of total US petroleum usage is in transportation. So transportation is the second most expensive spending category, typically for home expenses after the house itself. So biofuels can help in this critical sector. That's why biofuels, together with vehicles and fuel cells, is part of the Office of Transportation. So bioenergy is a renewable energy resource derived from biomass and can play an important role as we move towards supplementing fossil-based resources to reduce our dependence on volatile oil markets, that's the import, but also to increase exports of US energy, generating taxes and reinvestment in America through those exports. So either it's helping with reducing imports or increasing exports. Let's look at some biomass. So over here on the top here, agricultural residues. So here's some stover. This could be in a field, agricultural residues. This could be the farmer's second or third crop. What do I mean by that? Your first crop's always going to be food and feed and fiber. This could be the biomass, generating additional revenue there. Over here, this is a dedicated energy crop. So these could perhaps grow faster or like fast-growing trees or grasses, specifically grown for their energy use. Next, we're showing over here, this is an open pond. This is algae growing in the sunlight, turning that into oils. Over here, we have residues in the forest. So this is leftover wood and plant material from logging operations or forest management. You might be familiar with aspects of this. You've just pruned your garden or you've got some MSW. It's semi-sorted at this stage and then it goes into additional sorting. Sorted MSW. Let me stress here, this could be commercial, residential, yard trimmings, paper and cardboard. Anything that can be recycled should be recycled. But if it can't be recycled, there's an opportunity to bring that carbon in and use that waste stream to make biofuels and bioenergy. And then we can get into some even tougher stuff. Wet waste streams. What is he talking about here? Yes, I apologize, it is lunchtime. We are talking sewage sludge. So as the population grows, I think it's a very safe premise, wet waste sludge is probably going to grow in the future. This is a source of carbon that we can turn into fuels and energy. So it's deriving additional value from waste streams, and perhaps currently we have to truck away problematic waste streams. They're an expense. How can we turn an expense into a revenue? That's part of what we're trying to do here. So energy crops, they can generate economic benefits to growers as well as the environmental benefits. A farmer puts nutrients onto the field. He really hopes, or she really hopes, they stay with the crop. Sometimes they don't. They go off the field, into the streams, down through the rivers, and into the Gulf. And we have the Gulf hypoxia, the dead zone, because too many nutrients. You could grow energy crops at the edge of the field, and they're perennial crops. They grow year to year, and they have deep root systems, and they would uptake the nutrients, and then the nutrients would stay on the field, and the farmer could collect both the stover and the energy crop on the same field while keeping the water supply nice and clean and preventing a dead zone. So hopefully we're showing how biomass can help in this particular arena. So we move forward. So that's the biomass. So where can we go? Unique among other renewable energy sources. What do I mean by that? We can contribute to liquid fuels. We can make fuels that are drop-in, that are used current today's infrastructure. Yes, there's been significant breakthroughs in battery technology. That will need the changing of the fleet, which will take time. What do we do in the near and midterm? Biofuels is the answer. So what we're doing here is contributing to more stable, sustainable, economic, sound future, providing domestic clean energy sources and reducing US dependence on foreign oil. We can generate US jobs and revitalize, hopefully I've shown you, rural and urban environments. So we can convert it to fuels. Yes, you can make power from it, and we'll touch on how you can make renewable chemicals. Perhaps these as co-products to making fuels. Let's keep going. Now, there are particular segments of markets. Light duty, gasoline. Yes, fuel cells are making a huge impact there. So are batteries. What about in the heavy duty sector? What about in aviation and maritime? They need drop-in fuels. This is an opportunity for renewable aviation fuels. So it's advantageous to have that energy-dense liquid fuel working with fossil fuels together. Many biofuels are compatible with the nation's existing infrastructure, so you can drop into fleets, you can drop into pipelines, you don't have to worry about blend walls. And if you're making co-products, perhaps you have a waste stream where some of the biomass crosses into an aqueous stream and is a waste stream and you have to clean it up. That's an expense. If you can turn that into, take the rich chemistry within that biomass, turn it into products, maybe acids or esters, you can make additional products with your fuels generating higher values, higher return on investment than just burning or having to treat that waste stream. That is what is meant there. So repeatedly we've shown that you can make sustainably 1 billion tons, a potential for 1 billion tons in the US annually without disrupting food, feed, fiber, and exports. That's already in there. That's the billion-ton studies in 2005, 2011, and 2016. So by 2030, if you took that, you can make, using EIA estimates, by 2030, an electricity from biopower for 7 million households. Using literature, you could make about 50, looking at market partitions, 50 billion pounds of bio-based chemicals and products. The rest of the carbon could come over here, and we can make 50 billion gallons in fuels. If you were to do that, that's $260 billion could flow into the US economy. That's direct revenue. Indirect amplifies that effect. And that would add 1.1 million jobs across a variety of key sectors, like agriculture, through manufacturing, across the unique supply chain that we have in bioenergy. So let's talk about the Bioenergy Technologies Office. Where are we going to? Our vision, a thriving, sustainable bioeconomy fueled by innovative technologies. Okay, how do we get there? Developing and demonstrating transformative and revolutionary sustainable bioenergy technologies for a prosperous nation. Okay, and our goals, developing industrial relevant technologies to enable domestically produced biofuels, bioproducts without subsidies. We're about reducing risk, logistics risks, technical risks on moving forward with this technology and the intricacies and the complexities of scaling that up. It gets harder at scale. You can move a gram of biomass. Now try and move 100 million tons of biomass. How do you get the quality across 1 million tons of biomass, 1 billion tons of biomass? How do you turn biomass into a commodity? These are some of the challenges that we're wrestling with right now. So we do research, development, and demonstration to address these challenges. So initially, I would say up to about 2012, we were really focused on cellulosic ethanol because we work on non-food biomass. As FAO says, we've gone beyond food versus fuel. It's food and fuel. You need both. And fiber and feed. So we showed some R&D successes there, and we said, oh, okay, we haven't turned away from demonstration and pilot. There are some critical challenges that are still being addressed in the area, and we need to address those as we drive those from the first 1 or 2 commercial plants and start to grow that industry. But we've leveraged what we've learned there, and we're going towards drop-in fuels. Why? This is a barrel of crude. 42% goes into about gasoline, another 28% in diesel and heating oil, 9% in jet fuel, 15% in products, chemical products, and then some heavy fuel and some LPG. Ethanol is primarily in this 42%. What about the rest of the barrel? And so it occurred to us, we want to work on the whole barrel, so producing a range of products normally manufactured from a barrel of crude. And there are some instances with biomass being oxygenated, the polymers that are in biomass, the cellulose, the hemicellulose, and the lignin, that they can make oxygenated products more readily than perhaps starting from petroleum. So this helps us with our energy security and helps us with going towards products. So we're developing technologies to diversify energy supplies and boost US competitiveness. Let's highlight a few areas. Well, we touched a bit on aviation fuel. So Cathay Pacific and Amaris, they made an announcement this year about a 2-year program for flights from Toulouse to Hong Kong using Amaris's renewable fuel. And United and Altair announced a deal for regular commercial flights out of LAX on Altair's biofuel. And Alaska Air and Gevo, starting from woody residues, have been doing commercial flights. This is at a time when crude prices have been relatively low, and there's still this market pull from the aviation sector to work with renewable aviation fuels. LanzaTech is another example. They can take biomass and gasify it into gases, or they can even take waste gases from steel mill plants or from petroleum refineries to make renewable jet fuel from waste gases. And they're working with Boeing and Virgin Atlantic. They've got their fuel has passed its initial performance test, and they're working towards commercial demonstrations. Another area, again, apologize, it is lunchtime. Yes, they're wearing gloves. There's the sewage. And then you make a bio-oil. This is Pacific Northwest National Lab started this research on hydrothermal liquefaction to take sewage to this bio-crude, which then gets upgraded and ultimately can become these kind of fuels here. This is a technology, and let's take the context here. They're doing this in about 60 minutes. High pressure, high temperature. This is what the Earth has done over millions of years. Put down biomass, old algae, dinosaurs, squash them, apply heat, pressure, leave them there for millions of years, you make oil. We're doing it in less than 60 minutes. That's the size of the challenge. So we can make these bio-oil materials. We're beginning to see some of the biointermediates come and be used in FCC's, fluid catalytic cracking operations in existing petroleum refinery operations. That's through fast pyrolysis, and you could see that with HDL happening. If you did this, there's 34 billion gallons of sewage every day. That could make about 30 million barrels of bio-oil a year. That's from just sewage. Not going after all the other waste as well. There's a lot of manures out there as well, which we work on with our friends at USDA. I wanted to give you another example here. This is from upstate New York. This is New Holland, and SUNY, or State University of New York, developed a single cup and chip harvesting system for woody biocrops, shown right here. So it's more efficient. Through the logistics of this was introduced commercially in 2009. It doubles the output. It cuts the cost by a third. New Holland is selling these units, so this is manufacturing, commercialization in process. Fort Drum, an Army base in upstate New York, has a 60 megawatt biomass power plant that is partially fueled by the shrub willow harvested with this technology today. So hopefully I've shown you that biomass and waste streams enable us to reinvest in American industry and maintain an economic and technologically competitive advantage for years to come. Thank you very much for your time.